Bismillah ar-Rahman ar-Rahim. Today we will discuss lecture number 2 of nuclear chemistry. So today we have a topic radioactivity, causes of radioactivity. Okay, we will discuss in detail. So our first topic is radioactivity. We have to understand what's radioactivity. It is combination of two words, radio and activity. So here we can say that the word radio stands for the radiation and activity means the concentration or the amount of radiation. So basically radioactivity is a study of amount of radiation or the concentration of radiation of a particular radioactive element. So the first concept of radioactivity was given by Henry Becquerel. So Henry Becquerel discovered radioactivity. So from radioactivity, we can make a word radioactive, and this is activity means concentration. So if we see that the radioactivity shows that how much concentration or how much amount of radioactive substance is present in a certain, we can say, the radioactive nuclei. If we look the definition of radioactivity, so we can define it. It is the act of emitting the radiation spontaneously. It is a disintegration of atoms. So the process of disintegration or the process of splitting of heavy nuclei, okay, is a radioactivity. For example, if we say that we have the 1500 nuclei, if 1500 nuclei, there are the total 1500 nuclei, and out of the 1500 nuclei we have 260 stable nuclei and approximately 1240 are unstable nuclei. So radioactivity basically it is a nuclear process. It is not, we can say, the physical or the chemical process. It is a total nuclear process. So this nuclear process, this involves, we can say, the emission of alpha rays, emission of the beta and the gamma rays. Okay, how this radioactivity was discovered? So let's understand the, we can say, the basic mechanism, okay, that lead toward the discovery of radioactivity. For example, uh, what did Henry Becquerel uh, do? uh, he put certain, we can say, the uranium atoms. These are the uranium atoms that they are the wrapped in a black paper, and he found that certain radiation that they were passing through this silver foil, and again that they reached at the photographic plate. So here you can see here that the dark lines are the dark spots that appeared on the photographic plate. So he surprised in order to know that what made this photographic plate blackened. So he started working on this radiation, and finally that he discovered the concept of radioactivity. So in radioactivity, we have an important topic that is a stability belt or the zone. So what is a stability belt or the zone? So zone means this is we can say this is the area, or we can say where the certain nuclei that either they are stable or unstable. So we have to see. So belt, we can see here that the belt, this shows, this is the for the graph. So we have to see the graphically explanation that where the nuclei are stable and where they are unstable. For example, if we have atomic number less than 20, so we can say these atoms or nuclei are the most stable. if the neutron proton ratio is if it is equal to 1, it means that the number of neutron and the number of the neutron, okay, and the number of the proton, okay, if are equal, so neutron proton ratio will be 1. For example, if I say that this is the helium, the atomic number of helium is a 2 and the mass number is a 4, so the helium has 2 proton, the 2 neutron, and again I have the carbon, so carbon has 6, we can say, protons, and also the 6 neutron. Again, that I have this nitrogen, so you can see here this is 7 atomic number of nitrogen, 40 is atomic mass, so 7 proton, oh sorry, 7 neutron and 7 proton. Again we have the sodium and the magnesium. So we have to see that how the proton and the neutron exist within the nuclei of an atom, and what type interaction occurs, and how they interact and balance each other in a very similar nucleus. You can see here that this is the proton and this is a neutron. If we say this is the proton and this is the proton, okay, if I say this is a proton and this is a neutron and also this is a neutron, you can see here. So what happened, this a proton and this a proton repel each other, okay. Again you can see here this is neutron and this is also neutron. They can also interact with each other. This proton also can interact with each other, and this proton and this neutron also can interact with each other. This neutron, this proton can interact with each other. So actually that these are the interaction that occur among the certain nucleon of the atoms. So this interaction between these fundamental particles inside the nucleus continues. So therefore, the certain nuclei that they become stable, and when this interaction is weak, so we can say that the certain nuclei become unstable. We have to see here that uh, how a neutron is converted into proton, and how a proton is converted into a neutron. So we have to understand the basic concept of a zone stability, or we call it the stability belt. So we have this y-axis. You can see here that we have the y-axis, this is y-axis, and we have on y-axis that we have the number of neutron, and on the axis you can see here that we have the number of the proton. So we can say this is, we can say, the imaginary line that I have drawn. This is the imaginary line, and you can see here that this is, we can say, zigzag line, but this is not a straight one, but this is the zigzag line. And below this, we can see the red line that we have the certain number of the proton, and above this line that we have the certain number of the neutron. So if we start from here, from this up to this, we can say these nuclei, they are very stable because the neutron proton ratio is balanced. But as we move ahead, we can see that we have the large number of the neutron, the proton present in the certain nuclei. Therefore, the certain nuclei is either going toward instability or stability. For example, you can see here, if the number of neutron, okay, above this line, if number of the neutron is a greater, therefore that we have to decrease the neutron proton ratio. If below this line, if we have the neutron proton ratio, for example, neutron proton ratio, for example, if it is a smaller, then we have to increase it. So how can we increase it? We can increase it in the form of alpha emission, or we can say in the form of a beta positive decay. This is known as a positron. If we have in it to decrease the number of neutron, so therefore we have this a particle emission. This is a negatron or beta negative emission. For example, that we can see here through these nuclear equation. If we have the nitrogen, the atomic number of nitrogen is a 7, and it is, we can say the mass is a 12. If this nitrogen converted into carbon, you can see the carbon, and this we call it, this is the positron, okay, and this is antineutrino. This is antineutrino. So we can see here that what is happening here in this equation. You can see here that a proton is converted into neutron. Proton, because you see this is a proton. Proton is converted into neutron because we have to increase this ratio neutron proton. For example, if we have the large number of, for example, the protons, so the proton can be converted into the neutron. So here you can see here we have the 7 proton, and here we have the 6 proton. So here you can see here that the protons are excess. So this proton will be converted into a neutron, and the emission of a positron takes place. So what is the beta decay? Beta decay is represented by this symbol, is a conversion of a proton into a neutron. So beta decay basically is a conversion of a proton into a neutron.